Let us see the students of 11th standard. The last time we have studied about angular displacement, angular velocity, scalar relation between linear velocity and angular velocity, that is v equal to r omega. And then we have studied vector relation between linear velocity and angular velocity. That means linear velocity vector v can be written as equal to cross product of vector omega cross vector r, and that can be determined by using your right hand. Just you have to take your three fingers. This finger is along z axis, this finger is showing vector r, and this finger which is going inside perpendicular to the plane of the board is denoting vector v. So first vector cross second vector equal to third vector. Vector omega cross vector r equal to vector v. You can also rewrite second multiplied by third equal to first. That means vector r cross vector v equal to vector omega. Third vector cross first vector equal to second. This you have to keep in sequence. So vector v cross vector omega equal to vector r. But as given in your textbook, we consider first vector cross second vector, that is vector omega cross vector r equal to vector v, like this one. These are the three fingers of your right hand, and you have to keep it in strike position. So one vector is showing the cross product of other two vectors in sequence. So vector v equal to vector omega cross vector r. And now we have to discuss about angular acceleration. Angular acceleration, physical quantity in rotational motion, is similar to that of linear motion is similar to that of linear acceleration in linear motion. So we remember, in order to produce the linear acceleration, you have to apply the force. In order to produce the angular acceleration, you have to apply the torque. So here, if you consider there is a rotational motion of the three blades of the fan, when it is, and on the regulator, if you keep it is on number 1, it having a definite speed. If you slightly change the regulator number from 1 to 2, so whatever will be the time taken by you just to change the regulator number from 1 to 2 is the time taken to change the angular speed. So from that point of view, suppose instantaneous angular velocities of one of the particle of a rigid body which is rotating about the z-axis or fixed axis are vector omega at time t and vector omega plus delta omega at time t plus delta t respectively. So average angular acceleration, that is average of alpha, equal to change in angular velocity upon time interval. Change in angular velocity, that is final angular velocity omega plus delta omega minus omega, becoming delta omega, and time interval is delta t. T plus delta t minus t is delta t. So instantaneous angular acceleration, that is at any time t, is given by taking the limit delta t tends to 0 of this right hand side. So vector alpha equal to limit delta t tends to 0 of delta vector omega upon delta t, and that can be written as d vector omega upon dt. So thus instantaneous angular acceleration given by the equation alpha, vector alpha, equal to d vector omega upon dt, and it can be read as the rate of change of angular velocity. As you know, linear acceleration vector a equal to dv by dt. It can be read as the time rate of change of linear velocity equal to linear acceleration. Similarly, the time rate of change of angular velocity is known as angular acceleration. Angular acceleration being vector quantity, it must have a definite direction. So according to this equation, vector alpha and vector d omega, yani change in angular velocity, are in same direction. Means what? Vector alpha is in the same direction as that of vector omega. But we have seen that vector omega is in which direction? It is always along the axis of rotation. If the body is rotating like this one, then vector omega being in vertically upward direction. If the body is rotating like this one, that is in clockwise direction, then vector omega is going in downward direction. So accordingly, which will be the direction of omega, same with the direction of alpha. So its direction be the same as that of angular velocity. Then vector alpha is also along the direction of axis of rotation. Its unit, what will be its unit? The unit of omega radian per second, unit of time is second. So क्या मिलेगा radian per second square, or you can write revolutions per second square. And now we have to study about the important topic related with rotational motion, and it is the torque. Its other name is moment of force. Its third name is kappa. You will study later on, but at present we will say it is either torque or a moment of force. So what is torque? Torque is a physical quantity in rotational motion, is exactly similar to that of the force in linear motion. In short, whichever will be the role of the force be played in linear motion to produce linear acceleration, same kind of the role is played by torque in rotational motion to produce angular acceleration. So here, if a body is fixed above the axis of rotation, that means about a one line, or it is fixed at a one point. So if a body is fixed about a one point or along a line, then it has only rotational motion. If I consider this is the one kind of the slope is there, on the slope if you put a one small cylinder, then this cylinder will be rolled down, and as it will be rolled down, it possessing two kind of motion. One is rotational motion, as well as its center of mass is moving in straight direction. That's why it has a linear motion. That means rolling motion and rotational motion are not same. Rolling motion is the combination of two motions. One is rotational motion and another is linear motion. But out of these two, only one particular rotational motion can a body possesses curve. If a body is fixed about a one point, or if a body is fixed along a one line, and that line कौन सी होगी? Axis of rotation, then it has only a rotational motion. Now force is, जैसे आगे मैंने बताया, force is needed to produce a linear acceleration of a body. Similarly, torque is needed to produce angular acceleration of a rigid body. As for example, now we try to understand the example of your house. You know, in your house there are so many doors. Now if one of the door you want to open or one of the door you want to close, then what will you do? If I say this is the one kind of the door is there, and let you want to open, so here at the edge you will hold it and then you will pull it. In which direction you will pull it? You will pull it in a direction perpendicular to the plane of the door. And in that direction, if you are applying the force, then and only then the door can open. But if you are going to be applying the force on the door like this one, parallel to the plane of the door, then we can't it open or we can't it close it. तो यहाँ पे important है force लगाने का और किस direction में, how and where with the force is applied on a body, so it can produce rotational motion. So if you want to open or to close a door, then you have to apply force. कहाँ पे apply force करना है? At the edges of the door, in a direction perpendicular to the plane of the door. Then it will be most effective in producing rotational motion. That means उसको खोलने में most effective रहेगा. But if this kind of the force is applied parallel to the plane of the door, then it can't be effective in opening the door or it can't be effective in closing the door. Now let us see the torque acting on a particle. Most important, that can be asked in exam. So let us see about the topic torque acting on a particle. So here you have to consider this kind of 3-dimensional diagram. We remember, one is x-axis, y-axis, z-axis. This is origin of 3-dimensional coordinate system. This origin I will take as a reference point. If I say one point P or one particle P is lying in x, y, z plane, that is, it is lying in space. It is not in xy plane, it is not in yz plane, it is not in xz plane, but it is lying in the space. It is like this one. And now from this particle, if I allow to join it with origin, so you will get like this. There will be a position vector. तो मान लो पार्टिकल यहाँ पे है, तो ये आपको स्केल जो है देखिए ध्यान से एक्स वाई प्लेन में नहीं है, वाई जेड प्लेन में नहीं है, एक्स जेड प्लेन में नहीं है, कौन से प्लेन में? 3 डायमेंशन में, एक्स वाई जेड प्लेन, लाइक दिस वन. तो दिस इज दिस लेंथ ऑफ द स्केल यू कैन कंसिडर एज अ पोजीशन वेक्टर. पार्टिकल यहाँ पे है. अब मैं इसको थोड़ा नीचे रख के इस तरह से आपको बता सकता हूँ. तो ये पार्टिकल यहाँ पे है, तो ये क्या हुआ? इसका पोजीशन वेक्टर. अब ये पार्टिकल के ऊपर हम फोर्स लगाते हैं, किस डायरेक्शन में? ध्यान से. तो इसको हम इस डायरेक्शन में ऐसे फोर्स लगाते हैं. तो फोर्स लगाएंगे तो ये पार्टिकल कैसा? ध्यान से, किस डायरेक्शन में? यहां से होके इस तरह से ऐसे ऐसे गोल गोल घूमेगा. एंड दैट इज कॉल्ड रोटेशनल मोशन प्रोड्यूस हुआ. वही डायग्राम यहां पर देख लीजिएगा. So I take this is x-axis, y-axis, this is z-axis. P be the particle is lying in x, y, z plane. By joining it with origin, we get from O to P, vector OP equal to vector R is the position vector of such a particle with respect to origin, and origin is taken as reference point. Then we are applying the force on this particle like this one. देखिए ध्यान से. तो यहाँ से फोर्स लगा. अब ये फोर्स को पीछे की डायरेक्शन में एक्सटेंड किया, तो दिस एंटायर लाइन इज नोन एज द लाइन ऑफ एक्शन ऑफ द फोर्स. फ्रॉम द पॉइंट P in this direction the force is applied. तो फोर्स इज इन दिस डायरेक्शन, वेक्टर R इज इन दिस डायरेक्शन. ये वेक्टर R को मैंने पीछे की ओर एक्सटेंड किया, तो ये वेक्टर R यहाँ पे वेक्टर F के साथ जो एंगल बनाता है वो एंगल हुआ एंगल थीटा. तो थीटा इज द एंगल बिटवीन वेक्टर R एंड वेक्टर F. आप कहेंगे कि सर ये एंगल क्यों नहीं? क्योंकि ऑलवेज कोई भी दो वेक्टर के बीच का एंगल चाहिए तो दोनों वेक्टर कहां से लेने चाहिए? फ्रॉम कॉमन पॉइंट से. तो अगर ये वेक्टर R है और फिर यहीं से मैं वेक्टर F लेता हूं, देखिए उसी की डायरेक्शन को पैरेलल, ये वेक्टर R और ये वेक्टर F की डायरेक्शन में यहां से स्टार्ट करूं, तो ये आपको मिलेगा एंगल थीटा. By joining both the vector from one common point, you will get the angle. So from that point of view, you can say this is ये वेक्टर R को एक्सटेंड किया, तो यहाँ से वेक्टर R की डायरेक्शन है, यहाँ से वेक्टर F की डायरेक्शन है, और दो डायरेक्शन के बीच का ये एंगल थीटा. तो थीटा इज द एंगल बिटवीन वेक्टर R एंड वेक्टर F. Let F be the force acting on it. Theta is the angle between vector R and vector F. Now you take cross product as we have seen earlier. So cross product of this vector R and vector F with respect to the reference point O is known as the torque acting on a particle P. So here reference point is essential. Without writing these words, reference with respect to reference point, there is no importance of the torque. That's why reference point is necessary in the definition of the torque. The cross product of vector R and vector F with respect to the point O is known as the torque acting on particle P. So this torque is given by vector R cross vector F. So torque being a vector quantity because it is a cross product of two vector, and cross product of two vector gives always new physical quantity as a vector quantity. And as it is vector, it has two things, magnitude and direction. Magnitude of this torque equal to magnitude of vector R into magnitude of F into sine of the angle between them. And so here what is R and F? So R is magnitude of position vector R, and this R is equal to this R is equal to what? The distance from O to P, or you can say it equal to length OP, and F is the magnitude of the vector force F. Then what will be the dimension equation? Sin theta is dimensionless, तो R का dimension equation F का dimension equation, तो आपको मिलेगा total dimension equation m1 L square T raised to -2. and this dimension equation is equivalent to the dimension equation of work, dimension equation of energy. Unit of R is meter, unit of force is Newton. So what will be the unit of torque? The unit of torque is Newton meter, or you can write unit of torque is Joule, and dimensional equation of torque be the same as that of work and energy.